Lesson 2, Chapter 9. So we're going to keep on going through Chapter 9 theory. So we're talking about database concepts and file formats. If you have any questions about what we're discussing, please let me know. So let's keep going. What is the purpose of normalization? So remember, normalization, if you remember when we were working in Access, we would always have to import files into Access. Okay, so what we'd have to do is go to external data at the top, you go to text file, and you'd find the file that you want to import into Access. But if you recall, there were times that we had to manipulate the data that was in those Excel files. So we had to normalize it to 3NF form. That was like the 42 mark question. So what we'd do is in the Excel file, we would have to take out information which was related to each other, put it in its own file, remove the duplicates from the primary keys in that new file. Okay, in both files there should be no duplicates in the primary key, and then we'd make sure that each field in those files were related only on one key field. That was taking a normal data file that we found in Excel and making it into 3NF form. So what is the purpose of doing that? So normalization is the process of reorganizing data in a database so that it meets two basic requirements. There's no repeated data. So when we would do that, take information into its own separate Excel file, we'd remove the duplicates from the primary key. Okay, so we're removing the repeated data. Data dependencies are logical, so all related data items are stored together. So we take information that was related to each other and put it in its own Excel file. Normalization is important for many reasons, but chiefly because it allows databases to take up as little disk space as possible, resulting in increased performance. So when you remove duplicate data that is there unnecessarily, that will decrease the size of your database. And if it's taking up less size, it can run more efficiently. So that is the purpose of normalization. Describe the characteristics of data in unnormalized form, which is 0NF form, first normal form, second normal form, and third normal form. So usually the table that you're given in the beginning that you might have to import into Access, that might be in 0NF form most of the time. So that has the following features. Data is repeated. The table might not have a primary key. There might be repeating fields. Okay, so that is 0NF form. There might be duplicates, there might not be a primary key, and there might be repetition of data. 1NF form, okay, is having a table that has no repeating groups. So if you start with a table that might have repeating groups, and you separate it from that table into its own Excel file and remove the duplicates from that file, you then might have a 1NF form type of database if you had to import those tables into Access. So to go from 0NF form to 1NF form, you just have to remove repeating groups. To get to 2NF form, or second normal form, there should be no partial dependencies. In other words, every field in a table must be fully dependent on the primary key. And the last form is 3NF form, which is third normal form. There should be no dependencies between non-key attributes. So to go from 0NF form to 3NF form, pretty much you'd go through each of these steps. So to summarize how to go from this unnormalized form to third normal form, you would first of all take information that is related to each other and put it in its own Excel file. Then what you'd have to do is remove the duplicates from those files. So you'd look at the primary keys and remove the duplicates from those fields. And then once you've done that, you just make sure every other field in each of those files is dependent only on the primary key of those files. That is how you go from 0NF to 3NF. So that question is quite common. Okay, cool. But let me know if you have any questions. So to show you how this might work, the duplicate removing and how it saves some space, if you have a table with duplicates, like you see this table here, You can see you have 01, Dr. Hyde 03, and you can see that record, well, not record, but that information pitches up again, 01, Dr. Hyde 03, 01, Dr. Hyde 03. So this could be considered unnecessary repetition. But if you see this table here, a table with less duplicates, okay, so what we've done in this part is we've taken these three fields, Dr. ID, Doctor, and Room, because this information is related to each other, and we've put it in its own table. So it's unnecessary to say again 01 Dr. Hyde 03 because that's just the same. It's the same as this first record. So you only have to state it once here. But then what we would do is to form a relational database. We would connect Dr. ID to Dr. ID. So what would happen is if you were looking at Frank to see who his doctor is, you would look at the Dr. ID 01. The database would then go to Dr. ID 01 and it can read off Dr. Hyde. So doing this, you can see that we've removed this unnecessary repetition of data. We've removed these two columns from this table here. So the only field that's actually repeating itself from these three fields is just the Dr. ID. So removing off the extra two columns of repeated data saves a lot of space in this case. Okay, so I hope that makes sense. Just tell me if you need any help with this. What are the advantages of normalization? So the database does not have redundant data. It is smaller in size, so less money needs to be spent on storage. So less repeated information that is unnecessary doesn't have to be repeated. That reduces the size of your database, so you don't have to spend a lot of money on storage. Because there's less data to search through, it's much faster to run a query on the data. So remember in Access, you had to create queries where you would type in specific criteria in the criteria row. So when you'd run a query like that, because there's less data to search through, you would get results a lot faster in your query than if you had those duplicates present. Because there's no data duplication, there is better data integrity and less risk of mistakes. Because there's no data duplication, there is less chance of storing two or more different copies of the data. The last one, change can be made, which can instantly be cascaded across any related records. So all the information is linked in your relational database. If you change one table or one bit of information in one table, it's going to be picked up across every other table that's connected to that table. Okay, so basically across every single table in your relational database will be changed immediately. Okay. So those are the advantages of normalization. What are the disadvantages of normalization? You can end up with more tables than in an unnormalized database. The more tables and the more complex the database, the slower the queries can be to run. It is necessary to assign more relationships to interact with larger number of tables. With more tables, setting up queries can become more complex. So in a normalized database, let's call it that, for example, this would be okay. You only have three tables that are connected together. If we assume this is in third normal form, for example, then this would be fine. But you can see that as soon as you add lots of tables to your database, it can become a little bit more complicated. Okay, so the more tables you have, like in this image over here, the slower the queries can be to run because it's got to search through or work with all of these tables together. That can take some time. It is necessary to assign more relationships, okay, with more tables. So you can see that there are a lot more relationships between these tables. So it can become a little bit more complicated. And more tables, the query setup can be more complex. So hopefully this makes sense. So when there are less tables, normalization can be pretty good to use. But if you have a lot more tables, you have a lot more relationships, the slower the queries will run, etc. Explain what is meant by proprietary file formats. So these are files that have been made by software manufacturers only for use within their software. Using their own formats means that software manufacturers are free to make software features that will store data in a way that suits the software. They don't have to wait for a standard format that will adapt to the software's needs. So for example, we have used the Office suite. So you have Word, PowerPoint, Access, Excel, those type of programs. And for each of those programs, there is a file format that Microsoft has made, maybe specifically for those programs. So they don't have to wait for some other file format to be developed for them. They have made their own file format that works efficiently for that type of software. Okay, so using their format means that software manufacturers are free to make software features that will store data. Yeah, so basically, these file formats that have been made by these software manufacturers run very effectively in the programs that these software manufacturers have developed. What are some popular proprietary file formats? So you have doc files, so that's Microsoft Word. So pretty much everyone, I think, knows what a doc file is. And an MP3 file, that is just an audio file. So these are examples of proprietary file formats. So they're owned by companies, developed by the specific companies, and the code is copyrighted, trademarked, so it is illegal to access that coding, obviously unless they give you permission, but those are examples of proprietary file formats. Explain open source file formats and why open source file formats are needed. So these are opposite to proprietary file formats. Okay, these have been developed for use by any proprietary software or open source software. So you can have Microsoft Word, you can have an open source software maybe like OpenOffice that is free to download and free to use. So these open source file formats can be used by both of these types of programs. Can be used by Microsoft Word and OpenOffice. So in other words, by the proprietary software and also by the open source software. They are free from copyright, patent, and trademarks. Their structure is known publicly, so you can access the coding for these open source file formats. It's available to the public, and they have no copyright, etc. The main advantage is that these files can be shared between users of different software. So if, for example, someone is working in Microsoft Word, and, well, let's say OpenOffice, let's start with the open source file software. If they are working on a report or letter and they save it in an open source file format, then that format can be opened also by a person who has Microsoft Word. So you can send these files around and different softwares can read and open these file formats. They can hold back development, however, of open source software because new features will require the file format standard to be updated. So if you want to upgrade your open source software, so if OpenOffice wanted to upgrade their software, they would unfortunately also have to upgrade the file format. So that is one downfall. Examples of open source file formats. So you get .jpg, that is a graphics file. PNG, that's also a graphics file, and MPEG, which is a video file. Those are examples of open source file formats. I hope that was alright. Let me know if you have any questions. Thanks.